All right, welcome to this breakout session. So we will be talking about building microservices with containers on AWS using the 12-factor app pattern, and we will deploy those microservices everywhere. The 12-factor app is a methodology to create modern application so that you can get the efficiency, the scalability, and the cost savings for your organization as well as for your customers. So I'm Roman Jordan. I'm leading a team of developer advocates specialists at AWS. And this session has been prepared together with Donny Procurso and Corbis Bernard. Just a quick reminder, this is a level 300 type of session, and it's part of the build on session or track. So I expect you to have some experience with containers because we will do some coding and you'll see in details how we can build this infrastructure. All right? Good. So here's the agenda. We'll do a quick review of what Amazon Elastic Container Services is, so Amazon ECS, AWS Fargate, as well as Amazon ECS Anywhere. Then we'll discuss about the best practices that the 12-factor app is bringing to us in building microservices. And we'll build and release and operate that application with AWS CDK. There will be a lot of demos, so I'm going to switch between screens, and hopefully you will enjoy that. Few takeaways. I think this is not the first time you are hearing about the 12-factor app. What we wanted to do here is to give you some practical experience on how to implement the 12-factor app methodology to build your application. So we'll see how we can adopt that. We'll see how you can leverage AWS CDK to deploy your application, and also use AWS CDK to create CI/CD pipeline. We will also leverage ECS Anywhere to create an hybrid architecture where our application will be distributed between the cloud and on-premises. So let's start with containers. How do we develop with containers? So that's quite straightforward. Usually a developer like me would work on his IDE, on his workstation, package its application with a Docker, and then ship that to remote servers, in this case, Amazon ECS and AWS Fargate. So Amazon ECS, Amazon Elastic Container Service, is an orchestrator of containers, which is fully managed by AWS. So you have all the scalability, the advanced task placement, and a deep integration with the rest of the AWS platform. AWS Fargate is a compute option for Amazon ECS. AWS Fargate provides you a serverless experience when you want to run containers. So Amazon ECS can run containers on top of EC2, where you would have to manage your EC2 instances. With AWS Fargate, you don't manage anymore your EC2 instances. We do that for you, so that you don't have to manage the infrastructure. You just need to manage everything at the container level. And you can scale, you can launch quickly and easily your applications. And you pay based on price, based on utilization. Amazon ECS Anywhere has been announced at reInvent last year and was released in May of 2021. So ECS Anywhere is the extension of the Amazon ECS cluster running in your region on AWS, and you can extend that to anywhere. So on-premises, for example. So you don't need to run anymore your own container orchestrator on-premises. You could just deploy Amazon ECS Anywhere on your virtual machines on-prem, and we will manage everything for you. So you use the same tools and the APIs that you know with Amazon ECS for running your application, your workloads that are in the cloud or on-premises. Very high-level view of Amazon ECS Anywhere. As I said, it's an extension of the ECS cluster, which is in your region, extended to your data centers, for example. So the control plane resides in the cloud, in your region. So it is comprised of Amazon ECS, the cluster, and AWS Systems Manager. And on your servers, on your VMs that are running on premises, for example, then you deploy the two agents, ECS agent and the SSM agent, so the System Manager agent. So we can get control of your Linux environment and the Docker as well. So we can deploy application there. We've seen that in the demo. So going back to shipping our containers to the cloud, to ECS and Fargate. How do we do that? If you are new to ECS, if you are new to Amazon ECS, I would highly recommend you to use AWS Copilot. AWS Copilot is a CLI tool which is very opinionated that guides you in building and shipping your application to Amazon ECS. Why using Copilot? Because you have a guided experience to build your application, but also other components that can be related to your application, like an S3 bucket, a DynamoDB table, and so on and so forth, and a CI/CD pipeline as well. For this particular demo and this particular session, we're going to use CDK. Why? Because we want to demonstrate to you how to manage infrastructure as code, but also because ECS Anywhere is not supported yet by AWS Copilot. So we do that with AWS Cloud Development Kit. So the AWS Development Kit is an open source software development framework to model and provision your cloud resources using your favorite languages. So you can code your infrastructure using Java or .NET or TypeScript or Go, or Python. In this particular example, we're going to use Python. What I really like about AWS CDK is that as a developer, I don't have to understand the logic of YAML files, and I just code my infrastructure as I would code my application. So that's very easy. The barrier to entry is easy. So this is the application that we are going to build during that session. Look at the bottom of the image, right? Okay, so we have the developer which is pushing the code to GitHub, to a GitHub repository. We have a webhook which is configured on our code pipeline, so it's going to retrieve the code from GitHub and then it's going to process it to update or build the infrastructure. So meaning that with the CDK code, I'm going to define my Amazon ECR repository, my Amazon Route 53 hosted domain zones. I'm going to create my Amazon SNS and SQS, which form my PubSub architecture. I'm going to create my Amazon S3 bucket, my DynamoDB table, but also my ECS cluster, and the tasks that I'm going to run on Amazon ECS. In fact, this application will be expanded to my home, actually, where I'm running 2 Raspberry Pis. One of the container, the worker process image, will be deployed also in the cloud, but also on a Raspberry Pi. And as you can see here on this diagram, there's no side-to-side VPN connection between my home, between this Raspberry Pi and the AWS or my VPC. There's no need for that because I'm not using any native services that needs to run into the VPC. I can make DynamoDB, Amazon S3, SQS, and SNS calls directly over the internet. I just need to provision the right IAM roles for my particular task so that I can connect over the internet. And you can see here the control plane between Amazon ECS and AWS Systems Manager is also running across the internet. Of course, in real life, you probably want to have a more secure connection between your on-premises environment and a VPN. But for this particular demonstration, we wanted to make it easy and straightforward. So the application looked like this. All right, so this is This is the application, this is the front end. When I take a photo here, I'm uploading a picture of me to S3 through my API, and then the worker is going to work in the background and collect the image, and then add this label and as well an image. So depending on the worker and where the worker is operating, we will get an ARM logo or a AWS logo. So if I do it again with you now, it may or may not be AWS, but because actually it depends on which worker is going to pick it up. So this is again the Raspberry Pi. But if we do it several times, eventually we'll see some other tasks that are getting to run it. All right. So moving on to the 12-factor app principles. What we call 12-factor app is a set of principles, good practices, that leads to create more scalable, maintainable, and portable applications. In fact, if you combine the 12-factor app and with the microservices principles, it helps you really to get great scalable applications. Just as a reminder, microservices principles are organized around capabilities. We have a decentralized governance. We also decentralize the communication to eliminate bottlenecks. And we leverage infrastructure automation. So we leverage infrastructure automation to automate the building of images, the provisioning of the server or compute capabilities, as well as the infrastructure. And finally, we leverage automation for the placement of container instances or services. So moving on to the first principle, code base. So what you want actually is version control. And the most common way of doing that today is using Git. So you can use your GitHub, your AWS code commits, your Bitbucket, your GitLab to do that version control. So you have your code, you push it to a Git to a version control, and then you deploy a version. There's only one code base per application. That's the first principle. There's only one code base per application. But there will be many deploys of that app. So from this code repo, we are going to create different environment, different deploy actually. You could not, or this principle says that we should not have multiple applications sharing the same repository. So that's an anti-pattern that we want to avoid. The second factor is dependencies. So what you want is to declare all the dependencies that for your application to run. So you want to declare them and isolate them. So here, I'm going to create my dependencies, my code, and my binaries, and bundle them together in some form of artifacts. In this case, Docker. So I'm going to collect from PyPy my Python packages. I'm going to retrieve my code from GitHub, and I'm using also potentially some other binaries like images, and I'm packing that everything together in a Docker image. That Docker image will be deployed in different environments. We can use different versions of the code, but there will be always the same image. So the third important factor is configuration. And what it means is that we want to store the config in the environment. So the same container can be deployed to different environments, but the configuration, so the thing that makes the environment specific, we want to keep it on the host. And we will give that configuration at runtime to the container, so it can run. And on AWS, there are different ways of doing that. You can use You can pass on environment variables to the Docker image when you start your task on ECS, on Amazon ECS. You can store some information on AWS Systems Manager parameter store, where you can encrypt or not the images, the text or the variables that you want. You can use AWS Secrets Manager as well to manage your secrets. And finally, you can also use AWS App Config. So we'll look at that in more details in the code. So I'm going to flip. Okay, so this is one of my container, right? It's the worker process image. I can see that here I have my requirements.txt, which is basically my dependencies from Python, and then I have my Docker file, which aggregates the code, the dependencies in terms of Python, but also my fonts and all the images that I need to create my artifacts. So that's the part of my dependencies. The next one is, if I look at my code now in API here, it's in the app here, I have a series of environment variables that I want to retrieve that my Docker image is going to expect when it's going to be launched. So those are the environment variables that I need to pass on to my task when I'm going to start my service on AWS on Amazon ECS. We can see also that there are different ways for us to retrieve some information. So if I go to my code, my CDK code, and creating my backend, I'm also retrieving from SSM, so System Manager parameter store. I'm going to retrieve some value and pass them on to my container. So the variables that my image needs to run. So we were saying about we're talking about the worker process image. So those are the variables that my container is expecting that I'm going to pass on to my task when I'm creating the image on Fargate. The fourth principle is backing services. So what is a backing service? It's basically any service that the app is consuming over the network as part of its normal operation. So it could be a database, it could be an S3 bucket, it could be an API somewhere. And the best practice here is not to use IP addresses for sure, but it's always to use host names, CNAMEs, okay, URLs. URLs that you are going to provide to the container through environment variables or through other systems that we have just seen. So it's important that those backing services are declared in this way. Finally, the build, release, and run. Why I'm saying finally, because they are among the 12 factors, we have five. The five first are really about building the infrastructure, creating your automation and building. And the next factor are about the best practices, and you need to build your application, to architect your applications. So build, release, run. In the build phase, that's how you create your artifact, your Docker image, for example. And then you are going to release that. So you take your Docker image together with a config, and you are going to deploy that on Amazon ECS. So we are going to see that in more details. All right, so this is my code pipeline. You can see that there's nothing here. because I've not configured anything. I have my ECS clusters. I don't see anything because I've not created anything. So I'm going to my code. I'm going to zoom in on the CDK piece of my code. So I'm going to create my infrastructure in the cloud. So I'm just doing a CDK synth, which is basically testing that my CDK code is good. It's a good practice to do that before deploying to the cloud. All right, so then I do a CDK deploy all, and from there, CDK is going to create all the CloudFormation templates based on my Python code to configure my environment in the cloud. So it's going to create my IAM rules, and policies, my ECS cluster, my S3 bucket. But specifically here, what we are doing is that we are creating a CDK pipeline. So now we should see a CDK pipeline. And what that CDK pipeline is doing is that it's going to retrieve from GitHub my code for my application, but also for CDK. So I'm retrieving the code for the containers, but also for the infrastructure itself. And we are going to build that environment. So we are going to update the pipeline. So that's the magic with CDK pipeline. It can self-mutate, meaning that depending on the changes that I may or may not do on the CDK code, it's going to update and eventually change the infrastructure. So that's a powerful way to manage your infrastructure and having version control also on the code of your infrastructure, not only for the code for your application. So moving back to the code piece. So here I am on the CDK part, and the main file is app.py, where I'm going to declare a number of variables that I need to get access to my GitHub repo. So I need the owner, so that's my colleague Cobus, and the name of the repo, the branch that I want to connect, and also the token that I need for authenticating my code pipeline to retrieve the code. The next step is to create a repo stack on ECR. So ECR is our Elastic Container Registry to save and to be my repo for my containers once they are created by the pipeline. I'm also creating a DNS stack. So basically, this is the piece that is going to create my hosted zone on Route 53. So my domain, basically. And then the next step is to create my CDK pipeline, where I'm passing on a number of information. So let's deep dive into the CDK pipeline and look at what it looks like. Okay, so I have my source in GitHub, so I'm passing on the owner and the repo, so we know where to retrieve the information. I'm also indicating the branch. So in this case, there will be main and the OAuth token, so I can authenticate against my repo and retrieve the code. Next step would be for me to create the pipeline. So I'm going to create this code pipeline, and I'm going to call it CDK pipeline. And the first step is what I did on my workstation, so the CDK synth. So I'm going in this particular machine that I'm going to provision. I'm going to install AWS CDK, as you can see here in the list of commands. I install CDK. I install the requirements for my CDK to be able to run, and then I do a CDK synth. From there, at this stage, the CDK pipeline will know what they need to build and all the stacks that they need to build, all the stages. And I need to declare those stages now. So I'm going to create my staging environment with a domain and a validation phase as well. So the stage for my staging environment would be defined in what I called the My Photo Booth application, which is again another CDK stage that I'm going to have a look at. So the CDK stage is composed of the backend stack. So we are deploying the backend stack and the front-end stack. The backend stack is going to create all my S3 bucket, my VPC, my ECS cluster, my backend containers like the worker image and the API image. We're going to see that. So here I'm going to create my DynamoDB table. Oops, sorry. Okay. Yeah, this is where I'm creating my my DynamoDB table, my S3 bucket, my VPC, my cluster, the queue, so SQS, SNS as well with the topic, and then I'm going to create my tasks on Fargate and ECS. I'm giving the environment variables and so on. So what we're looking at here is, again, the CDK pipeline which is running. So I have to accelerate that. We see here that the next step after we update the pipeline is that we're going to create our Docker image. So the CDK pipeline will retrieve from our code the Docker file, and automatically will start creating some Docker images for us based on the Docker file. And then, based on what we created, it's going to create all my backend and my front end. So it takes some time, but eventually it will come. It will be up and running. So here, the first phase has succeeded, which is the backend. So if we are a bit patient, we can look at now we can have a look at ECS, because if the first phase of creating the backend has been successful, we can see that now we have a cluster of ECS with the two container images that are running, so the worker process image and the API. And eventually, the front end will come up as well, and at the end of it, we have just a simple test with a curl to get access to my URL, my staging environment, making sure that everything is ready. So here you can see that indeed I can see some HTML code that I retrieved from the curl command against my staging environment. So that's what I would expect for a build run phase. Actually, when we do a real environment, you probably want to do some more advanced testing. So for that, instead of doing the validating just the domain, we want to do an end-to-end type of testing against our environment to make sure that everything works. So the way of doing that is that we have defined here in the tests an integration test, which is going to check a set of different aspects, so making sure that our web URL and the API URL are running, that our services are running. So when I can upload an image, I would get a message that says that everything is working, but also we will process testing that the image has been processed correctly. So that's our testing. So what we are going to do now is that we are going to change our CDK pipeline, the code, the Python. So we instead of doing the domain validation with a simple curl, we are calling our integration tests. I'm still using the same source of the code, so that's good. But the commands are going to change because indeed I don't want to do this curl anymore. So the thing is that I'm going to retrieve my end-to-end test from my test integration folder. Okay, so I do a CD test integration, and then I'm going to install the Python packages that I need to be able to run my tests. So basically, I need to download PyTest, and then once I have everything, I'm going to use PyTest to run my code against my environment. And I said against my environment because the test is expecting some information. It's expecting, we should see that my web URL and my API URL. So I need to give them that, otherwise it's going to fail. So I'm going to create a new variable, test environment, with the code that, with the URL for the staging environment as well as for the API. So I'm creating my web URL. Maybe I can accelerate now. So basically I'm giving the staging domain, and I'm going to copy paste that and replace it for API. And then I'm good to go. So with those line of code, I'm actually changing the way my CDK pipeline is going to behave. So I just do a git commit to my GitHub. So I'm just saying that I'm adding the integration tests. And then I do a git push to my GitHub repo. And once it's done, the webhook on my code pipeline is going to detect that the source has changed. So it's going to retrieve my code again and rebuild my infrastructure accordingly. So you can see that there's a phase of self-mutate, where basically it's doing the difference between our former code and the new code, and it knows what it needs to change. And then the pipeline is going to move on again. So we are going to recreate our Docker images. We are going to redeploy our Docker images on the ECS, and eventually also do the integration tests. Okay, so we have an environment that works now. What we wanted originally is to run some of our containers on a Raspberry Pi on ECS Anywhere, remember? So when I'm using my CDK pipeline, what I'm doing is that I'm giving the order to CDK pipeline to create for me the Docker images. Unfortunately, today the CDK pipeline is not able to create ARM-based images. So I need to create containers specifically for my Python to run. And I'm going to create a new stage in my CDK pipeline so it creates this ARM image, and then I will be able to deploy to my Raspberry Pi. So this is why I have a Docker image build phase, where basically I'm going to pass on the command to create my container, upload that to my ECR repo, and retrieve that afterwards. So this is what this code is describing. Actually, we have the ECR repo with my stack name and the service that I want to run. I'm giving the instruction to Docker to create this environment. I'm creating the image tag with the right format. And then I'm declaring my repo here, and then I'm going to build my image, tag it the right way, going to push that image to my repo on ECR, and save that image and the tag of that image onto my parameter store, so I can use it elsewhere. Elsewhere being when I declare my ECS environment, my ECS Anywhere environment. So I need to add that code, which I'm doing here. So I'm creating a Docker image for my worker process image, meaning that it's going to retrieve that from my source, create the image for ARM64. And the next step is finally to add a stage for ECS Anywhere. So again, we do that with CDK. We use we are going to retrieve the variables that we need from our stack. So previously, when the backend was created, we created a S3 bucket. We created the DynamoDB table, the ECS cluster. So we need to find those information as well. So that's what we do here. We create an IAM role, so we can run ECS anywhere. We are going to retrieve this information that I said, so the ECS cluster, the DynamoDB table, the S3 bucket, the queue that the container needs to listen to, so they can process images, and other information. We are retrieving also the ECS cluster because, as I said, ECS Anywhere is an extension of your ECS cluster running in the cloud. So we need to retrieve that information that was created in the backend phase. And then once I have everything like this, I need also to retrieve my environment variables and pass them on to my task. So I'm going to create an ECS task for ECS Anywhere, and it's of type external. External means that it's something which is running outside of your cluster or outside of the cloud. We are adding the container to this task definition, which is the one that we just created and uploaded on ECR. So that's the ARM64 image of the worker process image, and we create a service for ECS based on the task and on the same cluster. And we give that task a number of role permissions policies, so you can access our S3 bucket, our DynamoDB table, and so on. So again, I'm going to declare that. So I'm adding a stage to my pipeline. This is the ECS Anywhere stage that we just discussed. And again, what we need to do now is just a git commit. So I don't need to deploy from my workstation the infrastructure. I just git commit and push to my GitHub repo, and the pipeline is going to retrieve that information from GitHub and self-mutate the pipeline, so it's going to create everything that we need for ECS Anywhere to run. So accelerating there, updating the pipeline, and you can see that here, once it has been, so here we have 5 steps, and once it has processed the self-mutation, we'll see that the 2 additional steps have been created. That's building my ARM image and building also my ECS Anywhere. So again, it's going to go through the same process of creating the Docker image for ECS, redeploying my ECS cluster and my environment. And then we will see ECS Anywhere. So building the ARM container image and ECS staging. So now we need to onboard our Raspberry Pi to ECS Anywhere, because we created a placeholder, if you want, in the cloud for that. We say that we want to run a task on ECS Anywhere, but we don't have actually an external instance to run that yet. So I'm going to my cluster. I can see now that I have my 3 services, so the API, the front end, and the worker process image that are running on Fargate. But here at the bottom, I have a new service with 0 running task of type external. That's ECS Anywhere. So I'm going to go to the cluster, and I'm going to add an ECS instance. So that's the way we declare our ECS Anywhere instance. So in this case, a Raspberry Pi. So I need to connect to my Raspberry Pi. Yeah, it's 70 seconds away from the cloud because it's home. So I'm SSH into my Raspberry Pi, accelerating there, making a bit bigger. So what I need to do now is to retrieve some information. So I'm accelerating that here. So again, back to this tab, ECS instance, I'm going to register external instance. So that's the way I'm going to onboard my Raspberry Pi into my cluster, my ECS cluster. So I follow that, and I'm just going to copy paste this command that has been generated, and which is valid for 5 minutes, roughly, so we can onboard my Raspberry Pi with security. So I need to change a few things here, just because my Raspberry Pi doesn't allow to write on the temp. And it doesn't work because I need to be root. And if I do a sudo, it won't work either. So I really need to do a sudo su root to make that happen. And then from there, the script that the ECS gave me is going to install all the agents, so the ECS agent, the SSM agent for me, but it's also going to add some libraries and some other dependencies that they need to run, including Docker. So it's going to install Docker if not installed. So you see that it's trying to install the SSM agent. All right. Number of things happening in the background. And eventually, the agent, the ECS agent, will be deployed. Trying to wait for ECS agent to start. And once it's done, I just do a Docker PS to look at my images that are running, and I can see that there's an ECS agent that has been deployed and running. So at this point, since I have my ECS agent running, I can go back to my ECS environment and check that this ECS instance is declared. So meaning that the ECS cluster knows that now they can deploy the service which I declared as external. And it's going to deploy that. So we need a couple of minutes because I need to download from ECR or push from ECR, specifically push from ECR. So there's no running task as we see here. So I need to accelerate. Yeah, I can have a look at AWS System Manager, Fleet Manager, because now my Raspberry Pi should show up here. So I can see that, and I could connect now. I could SSH from there into my Raspberry Pi. So I still don't have, as you see here, my staging ECS Anywhere environment. I have one desire task, but only 0 running tasks because it has not been deployed yet to my Raspberry Pi. And I need ECR to push the image down to my Raspberry Pi. And eventually, we'll see that a Docker PS will show that we have an image. Yeah, we can see here that we have this app for the boost repo worker process image that has been deployed on my Raspberry Pi. So finally, my staging environment is ready. And we did everything through code. So now going back, as I said earlier, the 5 first principles are really about building your infrastructure. The next ones are really about how you can, the best practices for you to create your application and design it or architect it. Yeah. So the 6th principle is to use stateless processes. So basically, you don't want to lose data if your container is crashing for any reasons. So that's why you want to store the data outside of your container, if possible, in a database or in a cache. And if the Docker image is crashing, you will restart a Docker image and another one, and which will be able to restart the job that failed, for example. So in our case, we are using DynamoDB, and we are also we could use a cache like Redis. The seventh principle is port binding. So that's quite obvious. I think that's quite straightforward. If several services are running on a single server, you can run them, you can bind them on the same port. So you need different ports for every Docker images that are running on a specific server. You could use then a load balancer to map a URL to a bunch of ports that you've defined. So I'm not going to demo that because it's quite straightforward. Concurrency, so that piece is interesting. So what the 12 factor is telling us is that that processes are first-class citizens. So we want to make sure that they are, we decouple them and we can manage concurrency and so scalability in a distributed way. So meaning that our services are divided into logical element. So my front end, my worker, my API, and they can scale out, meaning that we are going to create more instances of each container independently from each other. And that should be the case for each and every component that I'm going to use, like my DynamoDB should be able to scale as well, so we need to test that. So that gives you flexibility. A good way also to scale in this particular example is the fact that we are using a pub/sub architecture with Amazon SNS and Amazon SQS. So whenever the API is going to get a picture from my user, it's going to push that to S3 and update the queue, and then a worker will take over. So this is a good way also for us to scale. I don't want to go into the details of that. So disposability. So as we are scaling up and down, if we want to keep the elasticity of our environments and making sure that our application is able to scale, we need to make sure that the way we design our application is that it's disposable. So disposable means that we want fast launch, so they can be started very quickly or stopped at any moment. So we can have this elasticity. So fast launch, we really want to minimize the startup time of processes, and because you want to scale up very fast if you have a spike in terms of utilization. So the graceful shutdown is also super important because when you are retiring some containers or services, you want them to be able to shut down gracefully and catch the SIGTEMP signal. If you don't do that in the code, then the load balancer will still send some requests to that container because they will not know, and your users will get some 400 or 500 type of errors. So you don't want that to be the case, and also because you want your system to be able to react quickly to any scaling down environment. So if you are able to capture that SIGTEMP, then you will be able to scale down more quickly. Okay, so this is, I think, the most important one. So having dev and prod parity. As we saw earlier, the artifact that we created, the Docker image, will be deployed everywhere. It can be deployed in prod, it can be deployed on the staging environment, but also on your developer machine. So that's easy to reproduce, and you can really have those different environments. So the idea with these principles is to minimize the gap between the development and production. So you really want to make that small. And we are going to see that how we can do it. We can do it easily with CDK. All right, so we created our ECS staging environment. we can see that we have a staging cluster running and our tasks are running. And what I'm going to do now is I'm going to create my production environment. So I go back to my CDK pipeline file, and what I'm going to do is just a copy-paste. Just a copy-paste of my staging environment and changing a couple of variables so that it's going to create exactly the same environment. And that's the principle of dev prod priority. You want to have a small gap between your development environment and your testing environment, in your production environment. You don't want to have a Postgres SQL in staging and another database in production. You want to have the very same environment, so you can reproduce errors and develop more quickly. So again, I'm going to create a new stage with my photo booth application for production, but also because my staging environment has ECS Anywhere and we are extending to a Raspberry Pi, I need to do that again for my production environment. So I would need another Raspberry Pi. And so I'm again the way for me to push that new change on the infrastructure is just to do a git commit to my GitHub, push the code. The code will be retrieved by my pipeline, and we see that it's going to automatically self-mutate again. So we have new steps in gray that have been created. So we are recreating all our images. We are going to update our staging environment and also recreating my ECS Anywhere, or just updating, or just, and then we are creating this production environment again with different faces, and then we have the ECS Anywhere, and I'm going to again onboard my Raspberry Pi onto my production environment. So again, it's really critical for from a 12-factor point of view to have parity between the developer environment and the production environment. So we just saw how we can onboard a Raspberry Pi, so I'm going to accelerate there because it's not really meaningful there. Everything is done, and then I have indeed my worker environment, and the deploy is succeeded in prod. So dev prod priority, I insist on that because the 12-factor app is really designed for continuous deployment, and you do that by keeping the gap between the development and the production small. Logs are quite, I think, straightforward. You really want to treat the logs as event stream, and you export them externally to your containers, because if your container is crashing, you will lose everything. So you can use Amazon CloudWatch or your Splunk or your Datadog, any service that can collect your logs as a stream of events. So no need for demos there, I guess. Everyone gets that. And finally, the 12th factor is admin processes. So you want to treat your admin processes differently and externally to your application processes. So you will need anyway access to your environment. So to update the database or migrate the database, you need to repair some broken data. So there are many use cases for you to get that. So this principle means that you would not SSH into a running container, but you would create another process next to it, so to be able to operate and do all your admin tasks. So, and that's it. Those are our 12 factor. So key takeaways, I hope that this quick demo will inspire you to adopt the 12-factor application when you are creating new and modern applications. We see some example, and the code will be made available on AWS Code Samples on on GitHub. You will be able to use. You are able to use AWS CDK to deploy your application. So we focused on how to implement this CI/CD pipeline and to make it self-mutable with a CDK pipeline. And I think that's super powerful. And then we also saw how we can deploy an hybrid architecture with ECS Anywhere. Thank you. So if you have any questions, feel free. Thank you.